Okay, today we're going to be looking at identifying and solving proportions created by parallel lines. So we've got this picture to kind of start us off, and you can see, hey, they've got two intersecting transversals. So these are like the slanted lines are your transversals, right? On a line sheet of paper, and then the point A is this point at top where the two transversals intersect. And they're kind of assuming here, but think about this. This is just a line piece of paper. These lines are all parallel. And they give you some questions to think about here. I highly suggest that you go through and kind of try some of these questions because I think it brings some good ideas out. So if you want to pause the video and go ahead and take a look, I suggest it. So the first thing we want to do now is look at what convinced you that the two triangles are similar. So first of all, in case you missed it, they're talking about this smaller triangle on the top, and then they're talking about this larger triangle on the bottom. Sorry, not on the bottom. Yeah, well, I guess you could think about that as the bottom. The bigger triangle, right? So why are these two triangles similar? There's some different reasonings you could do. However, I think the easiest one is to see, hey, they've got this shared angle, A up at the top. And then because these are parallel lines, these angles at the bottom are corresponding. Similarly, you could say these angles on the right are also corresponding, so they are similar. So those angles are congruent, therefore the triangles are similar. You could say angle, angle, or you could think about it as angle, angle, angle will convince you that those triangles are similar. Okay, now it tells us to label the vertices. So it doesn't necessarily matter the order you do, but we can call this B, let's say this C, this D, and this E. And it wants you to write a series of proportions. And there's lots of ones that you could do. It actually helped us in class to have us kind of write the triangles so that we have one triangle ABC. The other triangle is ADE. And I think once we saw it like that, we were able to write some proportions. Like, hey, if I have side AB over the left side of the bigger triangle, AD, it would equal the right side of the smaller one, AC, over something like AE. That's not the only way to write it, right? I could even do something like, even using those same sides, like AB over AC. So I'm saying the left side over the right side of the small triangle equals the left side, AD, over the right side, AE, of the big triangle. And there's a few, there's multiple more, but here's one more just for kicks, like BC over DE equals AB over AC. And I think it's just good practice, and we kind of had a discussion here about which of these work, which do not. Be careful of some things, like some people are trying to say something like BD over, DE equals AB over BC. So something like that, we corrected things and said, okay, well, this isn't the whole side there, so we had to change that to like AD. So just be aware that you're making sure that your proportions stay equal. And then once again, just for time's sake, I'm going to skip this last question. But this next one was interesting. We actually went through here, and it proposes, Tristan says that BD over AB is equal to CE over AC. But then his friend Tia thinks that this is wrong because they're not the whole sides of the triangle. So we actually went through and measured these. So we got some measurements. We used centimeters in class, but we got that this side, I think, was 4 centimeters. And then this was, I'm trying to remember, sorry, give me 1 second here. Here's my measurements. Okay. That was 4 centimeters, and then this was 1.8 centimeters. And then this was 4.7 centimeters, and this was 2.1 centimeters. So if we label this or set it up in the same way Tristan had it, we had 1.8 over 4 is equal to 2.1 over 4.7. And then we just wanted to see, hey, are those the same proportions? So we divided it on our calculator, and we got 0.45 equals, and then on this one we got 0.4467. And we talked about it, depending on the way you measure exactly, it's pretty dang close, but it may not be exact. We talked about, hey, there's some room for error here because, we can't measure exactly. So therefore, Is Tristan or Tia correct? It would be Tristan actually was. Those proportions are equal. And then Tia wasn't quite convinced, so I did show you guys just a little bit of an algebraic proof. If we start off by splitting up the segment into AB plus BD, that equals segment AD. So those are congruent. Then we took AB divided by AB plus BD divided by AB equals AC over AC plus CE over AC. So then we get 1 plus BD over AB equals 1, right? Because you're dividing the same thing by itself. CE over AC, the 1's cancel out, and then this is a true statement. So this was just helpful for us to know that, hey, the sides are also proportional. It gives us some different options as we look at the back when we start solving. Okay, so let's go ahead and find some different angles. So we want to find X and Y. As we look at this picture, the only thing that's kind of labeled for us is 115. So we can maybe say, okay, what else is 115 degrees? Or I think in my class, they actually kind of saw, hey, this angle right here, and they said, well, if I do 180 minus 115, I get 65. So this is 65. Hey, if that's true, then 65, this angle here would also have to be 65. So it's x minus 10. We add 10 to both sides. We get that x is 75, which helps us because then we can label this top one as well. But then it was a little tricky to connect it over to y. We noticed that we had some vertical angles here. And then people said, okay, well then y, if we look at solving for this angle right here, we'd have 180 minus 75 minus 65 is equal to 40. So then y would be 180 minus 40. Or maybe you could have noticed that that was the exterior angle theorem. And you could have said, well, I could have added 75 and 65 and got 140 as well. Great. So we kind of remember the things we did about angles. We warmed up with that as well. Not only can we solve for angles, but we can also solve for sides. So the triangle proportionality theorem says that if a line is parallel to one side of a triangle that intersects the other two sides of the triangle, then the parallel lines divides these two sides proportionally. Okay, so if we want to find x, there's lots of different ways you could set up this proportion, but let's say I start with x. If I compare x and I stay on that same side to the 3, then I've got to go to the other side and do the same one. Start at the top, which is 5.5, corresponds with the x, and 2 corresponds with the 3. I could have done something too, like x corresponds with 5.5 equals, and then I start on the right side again, 3 over 2. Those proportions, right, and there's a couple of variations thereof, are going to give you the same answer. So just be aware there's multiple ways to set these up. As long as you have a true proportion, you'll get the same answer. As we cross multiply, we get 2x equals 3 times 5.5 is 16.5. Divide both sides by 2. X equals 8.25. Okay. This next one, we're looking for the length of CA. So we're looking for this length here. So this one, there's kind of two ways we could do it. I've seen students where they just find out the length of AD, and they say, okay, well, once I find AD, I can add 5. Or what other kids liked is they just called this whole length x, because then once I solve, I got my answer. And then we just said, okay, well, then we got to compare it to this whole side, because we got to keep our proportions equal. So this side, when you add 9 plus 16, we get this side length is 15. So like our long side, which is a total of x, over the other side, which is the long side is 15, equals, I also have this 5 that corresponds with the 6 on the other side. So now, once again, you just cross multiply. 5 times 15 is 75 equals 6x. Divide both sides by 6. X equals 12.5, and that's the length of CA. Okay, once again, same idea. This one even more so, I probably would use the entire side length. Because if we're solving for x, x corresponds with 3 on the other side. But if I wanted to represent like b to e, which corresponds to the 4, I'd have to do something like 21 minus x, and that's not easy. But I could say this whole side length is 7, so now I can compare 21 to 7. Once again, think about cross multiplying, and we get 7x equals 63. Divide both sides by 7, x equals 9. Okay, this time we have to find both x and y. So let's start off with x. Maybe you do something like x corresponds to the 3, and then the 15, which is on the same side of x, corresponds to the 9. So as you cross multiply, we end up with 45 equals 9x, which means that x equals, as you divide both sides by 9, x equals 5. Okay, then I'd want to do a similar thing with y. So maybe I start with the y, but y corresponds with the 12. Okay, so then I go, okay, let's go back to the small triangle. I know a side length of 3 corresponds with what? So in this case, you gotta be a little careful because you're gonna be tempted just to call it over 9. But notice that we did the whole side of the triangle, right? The whole base and the whole base, not just a portion of it. So we gotta do the whole side there, which is 12. So what does y equal? This one you may just be able to see, well, hey, for that to be equal, y also has to be 3. But you could also cross multiply and see that. Okay, so next one for you. We're going to find the value of x. So we got 3x plus 3, which that's the whole side length. So it's got to correspond with this whole side, which is 9, equals on that left side, we got a 10, which corresponds with on the top, the 6. Okay, as you cross multiply here, we get 90 equals. Remember that 6 has to apply to both the 3x and the 3. So we get 18x plus 18. Subtract 18 from both sides. We get 72 equals 18x. Divide both sides by 18. X equals 4. Okay, one last one here. So, set up your proportion. 2x plus 4, I just started with one of those values, right? Let's say it's over 5. If I do it that way, I got to do the same way kind of on the bottom. 3x plus 5 is that bottom larger piece, and then over the top piece is the 7. All you got to do is cross multiply. Don't forget to apply that 5 to both of those terms and the 7 to both of those. So when you multiply 5 times 3x, you get 15x. 5 times 5 is 25. 7 times 2 is 14x. And 7 times 4 is 28. Go ahead and solve for x. So let's move the 14x to the other side to get x on the same side. X plus 25 equals 28. So then here, just subtract 25 from both sides. X equals 3. Okay, one last idea. And this is kind of like pre-teaching us for the next lesson, but it says the Pythagorean theorem says, and I got a little triangle over here to remind us, but it says if we have a right triangle, or maybe I should say this, sides of a right triangle are a squared plus b squared equals c squared. So remember, c is always the one across from the right angle as the hypotenuse. So you'll notice here, hey, it doesn't matter which sides we call a and b, but maybe this is a, this is b. We're solving for the hypotenuse c here. So you're just plugging in numbers. You got 12 squared plus 9 squared equals c squared. So 12 squared plus 9 squared is 225 equals c squared. Take the square root of both sides. C equals technically plus or minus, or sorry, just 15 here. You're not going to have a negative side length, although we usually do plus or minus, right? Okay. How about for this next one? This next one, you'll notice I actually have c. C is the 16. So this is kind of like your A's and your B, right? We're going to solve for one of those. So this time, we're in your equation at 14 squared plus x squared equals 16 squared. I usually just rewrite what like 14 squared is, so that's 196, plus x squared equals 16 squared is 256. So I think when you see it in that format, you guys are more used to solving for it. So go ahead and subtract 196 from both sides. X squared equals 60. And then go ahead and divide both sides by the square root. And we got to figure out what is the square root of 60. So ask yourself, what does that break down to? 6 and 10, 2 and 3, 2 and 5, so we got a set of 2's. That means the 2 comes out. 3 times 5 will stay inside. That's 15. And that's going to be an exact answer there. Okay, you should be all set for your homework now. Good luck.